Next is eigenvalues. Let us consider linear transformation, and standard equation is given by y is equals to ax. Alright, let me choose different color. Y is equals to ax, which transforms a column vector x into column vector y by means of any square matrix A. Alright, so this is what it means. Now if that happens, and if that is the case, then we can say that A minus lambda I is equals to 0. So this is also known as characteristics equation. Let us understand with the help of an example. This numerical example says that we need to find eigenvalues of A. Alright, so matrix A is given as 4, 1, 3 and 2. Alright, so let us see solution. We know that eigenvalues has a characteristics equation of A minus lambda I is equals to 0. So we know that A is, alright, and minus of lambda, we need to introduce identity matrix. So here in question we have 2 cross 2 matrices. So if it is provided 2 cross 2 matrices, so we need to introduce I2. So in order to introduce I2 is 0, 1 and 1, 0. Alright, then whole determinant is equals to 0. Again 4, 1, 3 and 2. Since we know that this is a scalar multiplication, so our answer will be lambda 0, 0 and lambda. Simply we multiply this scalar with the matrix. Alright, what we get? 4 minus lambda, 3 minus 0 is 3, 1 minus 0 is 1 and 2 minus lambda is 2 minus lambda. So this is whole determinant equals to 0. Since it is 2 cross 2, so we take determinant as 4 minus lambda into 2 minus lambda minus 3 multiplied by 1, which is equals to 0. If we solve it, we get lambda square minus 6 lambda plus 5 equals 0. Now if we take the middle term factor, lambda square minus 5 plus 1 is 6 and 5 times 1 is 5. Alright, so lambda plus 5 equals 0, and lambda square minus 5 lambda minus lambda plus 5 equals 0. If we take lambda common, so lambda minus 5 will be there, and if we take minus 1, lambda minus 5 will be there. Alright, now lambda minus 5 is one term and lambda minus 1 is another term, and if we equate lambda minus 5 equals 0 and other value, we get lambda minus 1 equals 0. So from here we get 5 and from here we get 1. Alright, so for lambda value we get 1 and 5, and this is known as eigenvalues. Alright.